So hey everyone, welcome to this video. We are done with day one coding questions. We have done almost around 5 to 6 coding questions, which sum up to 5,000 around 300 rating. So I'll walk you through all the questions. I wanted to do live stream, but as I made a new account, so it will require around 24 hours before I can start live stream. So today I'm making video, but maybe from tomorrow onwards I'll do live stream of the question. So let's start with the question only. Okay, yes. So it's our college compiler. I wrote all the um, code here only. So let's get started. Okay. So first question we did was 2231A. Yeah, this one. So what was this question? Yeah. So we have to construct an array, and it will be all, the size will be given in the input, and we can use numbers between 1 to 2 into n, 2 into the size of array, which is n. So we can choose element from these numbers only, this range only, and we have to uh, make an array so that the sum of first two element and okay, so okay, let's take an example. Let's say we have this array. So 8 plus 1 is 9. So we will add 9 at the end of the array. Let's suppose we are not actually adding that, but let's suppose. So now we have added 9 here, then we will do 1 plus 11, then we will do 2 plus 11, then 3 plus 2, then 4 plus 3, and we will add all these numbers at the end of the array. So let's say this forms a new array. So in this new array, there should not be two equal elements, or you can say two same elements. So all elements in this array should be distinct. So we have to create an array like this so that sum of all the adjacent elements, if we append them in this array, then also all the elements should be distinct. So we have to make a array like this. So what I did for this, it was very simple question. So what I did was, uh, yes. So this is the number of test cases. This is the size of array. Then what I'm doing is uh, I am appending the maximum element that I can insert in our array, and maximum element, then second maximum, then third maximum, then fourth maximum. So what will happen is, let's say we have to make an array of size 5. So what I'll do is I'll make an array in which first I will append 10, then 9, then 8. Oh, I'm writing this on my scratch pad. 6, 5. Oh, sorry. How to do undo? Yeah. 9, 8, 7, say. Undo. Yeah. And your user. Okay. So this will be our array. There are 5 elements, so this will be our array. So it will work or not? Let's see. So 10 plus 9 is 19. So if we make the imaginary array as this, in which we have appended 9, 19, then we will append 9 plus 8, which is 17. then 8 plus 7, which is 15, then 7 plus 6, which is 13. So you can say all the elements, you can see all the elements are distinct. So I thought of this solution. There can be multiple solutions to this, but this was the easiest one, or you can say the first one that came to my mind. So I used this. Okay. Uh, this was a very easy one. Uh, Today I was doing only easy question so that I can start because I was not doing a lot of questions from a very long time. Okay. So this is our second question. Okay, let's first understand the question. Yeah. So the question was, will be given a string with the parentheses, opening and closing parentheses. So what we have to do is, uh, we have to make them valid parentheses after, let's say, taking one and taking any substring from this string and changing its position anywhere. So let's say we pick up this string and put it at the front, so it will be a it will become a valid string. So we can choose any substring and place it anywhere in the remaining string. So after doing this, we have to answer whether we can make a valid string or not. So for this, okay. So the condition here would be, mm, yes. So think of any substring, any string with opening closing parenthesis. So first, let's say uh, we have a opening. Okay, first we are making a valid parenthesis string. So how it will look after every for every opening there will be a closing after that opening bracket. So this this is a valid substring, valid string. Yes, yes. This this is a valid string. Yes. So for every opening there is a closing after that opening. Understood? So that we call a valid parenthesis string. Okay. So now, so when it will be not valid? So it will be not valid when we have a closing parenthesis before a opening parenthesis. Then it will be invalid. Okay. So let's directly jump onto the solution. It is a very easy question. You can easily understand by the solution itself. So let's say we have a string like this. Okay, so you can see here it is invalid because we have only one opening parenthesis and we have two closing parentheses after that. So there should be one more opening parenthesis, then it will be valid. So and for this opening parenthesis there is no closing parenthesis after it. Okay. You can see this is valid in itself, this is valid in itself, this is valid in itself, but this and this is not valid. You can see that. So what I have done is, okay, so I am taking the the opening parenthesis as plus 1 and the closing parenthesis as minus 1. Okay, so it is plus 1 minus 1 0. Then it is minus 1. Then it is plus 1 0. Here it will 0. Here it will minus 1. Here it will be 0. Then here it will be 1. Then here it will be 0. Okay, understood? So, if you know, in a valid parenthesis, there cannot be minus 1 anywhere in this array. There should not be minus 1 present in at any place in this array for a valid string. But our string is invalid, so there is a minus 1 here. Uh, it will be 0 after summing up. So it will be 1 0 minus 1 0 minus 1 0 1 0. Okay. So what I did is uh, where there is the maximum, you can say there is the maximum lowest number. So which is, you can say, maximum negative number. Where there is a maximum negative number, uh, from thereafter I'll cut the array and put it at the front. So tell me whether it will make sense, or we will get the answer or not. So uh, after solving some of the examples, I got to the solution that it will work all. It will always work, because what is our definition of valid parenthesis, which is for every opening there is a closing after that. Okay, so what we are doing, where there is the maximum negative, I am putting all the parentheses after it before that. So for the opening which do not have any closing bracket, it will get a closing bracket here. Okay, but there is a condition. The number of opening brackets should be equal to the number of closing brackets in the original array that is given to us. Okay, so that is the only condition. And uh, in all case, where there is a equal number of opening and closing, we can make it a valid parenthesis. Okay, let's see an example. Let's see this one. So it is like that. Okay, so if we assign numbers to them, so it will be 1, it will be 0, then it will be minus 1, then 0 1 0. Okay, so first we have to check whether the number of opening and closing parentheses are same. So here you can see both are same in number. So what we will do, where we will get the lowest number, or you can say maximum negative number, then after that we will cut the string and put the string after the cut in the front. So it will be like this. So you can see we get a valid string. So that's how I solved this question. It was also 818 question, so it was also easy. Okay, so what what I'm checking is whether the number of opening parentheses equals to number of closing parentheses. That is the only condition that we have to take care of. And I have also written the solution. See if the open and close are same. If closing are before open, then cut the string at the lowest point and put the second part in the first, or you can say in the in front, whatever. Okay. So this is the second question we solved. Then third one was a 918 question. Okay. So let's get to it. 2200C. Yeah. So okay. So this question was something like you have to choose two indexes I and j, and between I and j all of the elements should be between I and j all of the elements should be star. Okay, so you have to choose two I and j like this, in between which all the elements are star, and the element at ith position and the element at jth position should be equal. Okay, if this condition satisfied, then we can also make the elements at ith position and element at jth position equals to star. So uh, let's say we have L star star L. So this will become star 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 star. Okay, okay. So we have to return whether we can make the whole string equals to मतलब every element equals to star. We have to return yes or no whether we can make every element star or not. Okay, and if I and jth position are adjacent, so there are no elements in between, then we can make them star also. Okay, so let's see example. Okay, let's see. Let's say we have L U U L. Then what we can do? We have to make all of them equals to star. So what we can do is uh, we can choose I at position 2 and j at position 3 and make them equals to star. Okay, then we can choose position 1 and 4, and now between 1 and 4 both the elements are star, and the element at position 1 and 4 are equal, so we can also make them star. So we can convert the whole string into star, so we will return yes. Okay, now let's take an example. Okay, this example, this is, I will not say hard, but still a longer one. S I I S I I S I X X X X S E V V E N N S E V V E N N. So here you can see these both are same, these both are same, these are same. So let's directly convert it to star. So our string will become like S star 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 star, then S E star star E, and this is also same. So star star. So here you can see these elements are same and between them are all stars. These elements are same and between them are all stars. So our string will be all become star. So this is the solution for this. So what I have used. Okay, so this is how the question works. Now we will get up to solution. Okay, let's take this example only. Uh, yes. Okay. So what we have used in the solution is we have used stack. So what is an stack is? Stack is last in first out. So stack is something like this. Okay, we put something into stack and like this. We put another thing, then another. And then when we have to take out something, then we will take out from the top itself. So it's like you can say a bucket. Okay, so this is how stack works. Now why we use stack? So let's see with this example only. We have a stack. First we put s in it. Okay, then I, then again. When we are going to put I in the stack, we will check whether it is equal to the already present element at the top. Okay, so I came here, we will check whether it is equal to the top element. If yes, then we will remove the top element and we will not insert this element into the stack. Okay, so we have removed the element I, then we will put, then x comes and we will check whether x is equals to s or not. So it is not equal to x, so we will put x in the stack. Okay, then the second x will come, then we'll check, so it is equal, so we will remove the top x. Then s will come, s is equals to what is present at the top, so we will remove this s also. So our stack become empty. Now E will come. So if our stack is empty, then whatever comes, we will directly put it inside. So A will come, then V come, then again V come, then these both are equal, then V comes out, then this E come, and when it is going to enter, we will check it is also in there. So we will remove this E also, and then similarly with both these and. So at last our stack will be empty. So if at last our stack will be empty, then yes, we can make all these as stars. So do you think this solution works everywhere or not? Do you think so? So yes, it will work because we are checking adjacent elements whether they are same or not. If they are same, then we are removing it. Okay, so it will work. Let's get to the code. So here I am taking the input string. I am making a list stack. A list equals to stack. Stack is ultimately a list only. Okay. Then I am looping over the input string and I am checking whether there is something in the stack or not. If there is nothing in the stack, then I am directly appending the element, the current element. If there is something in the stack, then I'll check whether the current element is equals to the last element of the array, which is the top element of the stack. If both are equal, then I'll remove the top element from the stack and will not append the current element in the stack. So at last, if our stack is not empty, which means some element, there's some elements which are not equal and adjacent. So if our stack is not empty, the answer will be no. If it is empty at last, so our answer will be yes. We can make all elements as stars. Okay, so this was the third question. It was a 918 question. Let's move on to the fourth question. Okay, so it is 1811B. Yes. So it was also a very easy question. I have written a lot of if else. I am damn sure that it has a very easy solution, but I have solved it by what came first in my mind. So I'll walk you through my solution. Okay, so what we have to do here is these are all conveyor belts of n cross n size. Okay, uh, n will be given us in the input. So there's a conveyor belt of n cross n size, and uh, it was like a spiral. There is a conveyor belt at the outer side, then there is another conveyor belt in the inner side, then again, then it will go on up till the end. Okay, and n is a even number, so it will be a even cross even size. You can say conveyor belts or matrix. You can say. Okay, so there is so we have two positions. Let's say we have one cross one comma one, and we have 3 comma 4. So 1 2 3 comma 1 2 3 4. So we have 1 comma 1 and 3 comma 4. So we have to go from 1 comma 1 to 3 comma 4. So uh, we have to output, we have to give the output as how many jumps we have to make to come uh, here at this position. Okay, and we can jump like this, the adjacent uh, squares, and the we can also jump to cross squares, we can, or diagonally. Okay, so if I have to come here from here, then what I'll do, I'll jump here, then here. So in three jumps I will get to this position. Okay, but the thing is, this conveyor belt is moving, and whatever it will there will be in this position, it will move to here, then here, and it will come to this place uh, one time. So if we reach here by jumping from here, then here, if we come to this position, then anyhow the conveyor belt will move to this direction, so we can reach to this position. So the minimum number of jumps that we have to make are only two, one, two. Okay, so we have to return the minimum number of jumps we have to make to reach a certain position, and the conveyor belt is always moving. Okay, so let's take an example. Let's understand this with an example. 41433. Okay, so we have a 4 cross 4 conveyor belt. You can say matrix. We will not say conveyor belt, we will say matrix. should look like this only. Yes, I think it's right. Okay. Wait a minute. Wait a minute. Okay. So our 4 cross 4 conveyor belt will look like this. Mm, it will look like this. That's all. This is how a 4 cross 4 you can say matrix will look like. Okay. So conveyor belt will move like this, and this. Okay. So we have to go from okay. So we have to go from 1 comma 4 to 3 comma 3. So 1, 2, 3, 4. 1 comma 4 is here, and we have to go to 3 comma 3 here. Okay. So this conveyor belt will move like this. Okay. So we have to reach here. If we reach here only, then the conveyor belt will move to this direction. So we can reach here. So minimum jump we have to make is only one. We have to jump from this position to this position. So the answer will be one. Okay. So that's how we have to do this. So now, uh, can you think of something like if I am uh, if I am in this conveyor belt, and I know that my point lies in this conveyor belt, so I can directly, let's say this conveyor belt is, we are giving numbers to the conveyor belt, and the conveyor belt just inside this conveyor belt we give it, the number 2 to it. So if we get to know in which numbered conveyor belt are this point lies, then we can directly subtract the we can directly subtract this conveyor belt number from this conveyor belt number. Okay, so if we subtract 2 from 1, then we'll get minus 1. So we can, if we take absolute of this, then we'll get 1. So we can say we have to only make one jump to get to this conveyor belt, and this conveyor belt will move, and we will ultimately get to this position. Okay, so what you have to find is, you have to just find in which conveyor belt this point lies, and which conveyor belt in which conveyor belt uh, this lies, and we will just take the difference between both the conveyor belt, and that will be our answer. Because in every jump we can jump to the inner conveyor belt or the outer conveyor belt. So in one jump we can change the belt. So our answer will be the difference between both the belts. Okay. So I have written a big code for this, but let's get to it. It is easy to understand. We can do this easily. So first I am taking the positions of both the points and the size of the matrix. Okay. So what I am doing is, Let's make 4 cross 4 and okay. What I'm doing is okay. So this is a conveyor belt. This is a conveyor belt. Okay. So wherever is my point, uh, let's say my point is here, the initial point, and I have to go to this point. So ultimately, what I have to do? I have to go from here to here. Okay. So can you see that uh, it is this uh, going to this distance is equivalent to going from here to here. Can you see that? Okay. So what I am doing is uh, okay. If my initial position is greater than if my initial position, which is this, it is x1 comma y1, it is x2 comma y2. Okay. So if x1 is greater than n by 2, n is 4, so n by 2 is 2. So x1 is 4, x1 is 4, so which is greater than 2. So what I am doing is I am subtracting it from n plus 1. Okay, n plus 1 is 5. I am subtracting x1 from n plus 1. So 5 minus 4 equals to 1. So x1 will equals to x1 equals to 1. Similarly, I am doing this with y1. Y1 will also equals to 1. So x1 comma y1 is now this one. Understood? Same thing I am doing with x2 comma y2. So if you do the same thing, you will get x2 comma y2 as this one. You can see the problem is the same. You will get the same answer with this also and with this also. Okay. So why I'm doing this? So if I'm anywhere, if 2 points are anywhere and if the conveyor belt is rotating like this, so if I reach from here to here or here to here, that will be that is the same thing. Or from here to here or here to here, that is the same thing. Or from here to here, from this position to this position, and from this position to this position, this is the same thing. So I am dividing this matrix into four sections. Wait a second. Into four sections, and I am only calculating things in this section because this will give us the because let's say if our point is here, then it will automatically okay. Our we have to go here originally. So if we reach here, then automatically we will get to here. So I am restricting my calculation to this. You can say quarter only. Understood? So this is I am doing with all the points. I am making it under this quarter or in this quarter you can say. Okay. So once I have done this, what I am now what I am doing is let's make a 3 cross 3 matrix. Uh, we have seen that we can take an only even numbers, but now we are taking a 3 cross 3 matrix just for example. It will maybe look like this. Maybe, okay. Uh, we don't need actual calculation right now. So this is our first row. this is second, and this is third, this is fourth, this is fifth, and this is sixth. Okay, okay, okay. This is the one, two, three, four, five, six. This is a 6 cross 6 matrix. So yeah, 6 cross 6. Okay, 6 is even. Yeah, yeah. N equals to 6 will work. Okay. So this is a 6 cross 6 matrix. So you can see there's another color. Color. Okay. Okay. I don't know how to change the color. We will do it later. Okay. So this is one conveyor belt, the outer one, and this is another, and this is. So there are three conveyor belts. Okay. Okay. So if we are in row one, you can see if we jump from here to here, we are not changing the conveyor belt. We are on the same conveyor belt. If we jump from here to here, then we are in the same conveyor belt. Okay. So in row one, if we jump to the right side, then there is no change in the conveyor belt. But if we are in the second row, first position, then if we make a jump, then we will change one conveyor belt. But if we again jump, we will not change any conveyor belt. Similarly, it goes on. And if we are here, then if we are making one jump, then we are changing one conveyor belt. If we are making two jumps, then we are changing two conveyor belts. Then it will not change. So in position in row one, we can change at max zero conveyor belt. In second row, we can change at max one conveyor. In third row, we can change at max two conveyor belt. So in ith row, you can say in ith row, you can change I minus one conveyor belt. Okay, we are not going down from this quarter because we have made our calculations uh, restricted to this quarter only. Understood? So we will not go below it. Okay. Okay. So the change is the maximum change that we can do in the you can say ith conveyor belt. Okay. Okay. Now belt one represents the belt in which our x1 comma y1 lies, and belt 2 represent the belt in which our x2 comma y2 lies, and their difference will be our final answer. Okay. Okay. So I'm just checking in which uh, conveyor belt our point lies. Okay. So let's say we are in the third row. So okay, we have the initial point as 3 comma 2. So in the third row, how many belts we can change? We can change two belts. So if we are in the second position, so if we are here, we change one belt. So our uh, okay, initially we were in belt number one. Now we are in belt number two. So I am calculating the belt in which our x comma 1 x1 comma y1 lies. Okay. Okay. I have not actually used it here. Okay. remove this change, then it will work. Let me put change here. Okay, that that also works. This also works. But for clarification, let's put change here. So if our column number is less than the maximum change we can do, then uh, let's say maximum change we can do in this row is 2, and if our column number is less than or equals to 2, then we have already changed how many conveyor belts. We have changed y1 number of conveyor belts. Okay, so if our y1 is less than the maximum change in that row, then we have changed y1 conveyor belts. Okay, so then I am making plus equals to y1. But if we are, let's say, uh, we are we okay, let's say our point is 2 comma 3. Okay, this point. So how many belts we can change? We can change only one, but our y1 value is 3. So if y1 is greater than the change, so I am adding the change into it. So as I have taken the initial value of belt equals to 0, that's why I am adding x1. Okay. We can also write minimum of y1 comma x1 x1 minus 1 here. No, yeah, this one. Okay. Similarly, I am doing this with x2 comma y2. I am taking their, uh, I am trying to find their belt number, and once I get to know both the belt numbers, I am just taking their difference and their absolute difference. So that will be our final answer. I hope I was able to describe my solution well. But if you didn't understood anything, or you can say you are confused in anything, then you can ask me in the comments. I'll try to elaborate it more. Okay, okay. Then after that we have done a 1100 rating question. It is 2043B. 2043B. So okay, it is a very simple question. Uh, it seems very simple, and it is also very simple if you know a little bit of math. Then it is very simple question. Okay, so we have given two numbers n and d, and we will make a new number using n and d, which is n factorial times d. Okay, you can see wrote the digit d on a wrote wrote digit d on the board exactly n factorial times. So there will be n factorial digits, and each digit will be equal to d. Now you have to output, you have to return whether it is divisible by 1, 3, 5, 7, and 9. So you have to show all the numbers, all the odd numbers that divide that number, and they are also less than 9, less than equals to 9. Okay, so at first it seems very easy question. It is a little bit tricky. I will not say hard. I will say it is a little bit tricky. We will directly move to solve solution. It is very easy. Okay. So 1 divides every number. So 1 is the divisor of all. Okay. Then we will see 3. For 3, what we can do is uh, what we did for 3 is Okay, all the numbers are of form. Can you see that all the numbers are divisible by 11 if n is greater than 1? Because all numbers are like D, 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 D. I will say all the numbers are divisible by 11. You can say all the number are of form D into 1, 1, 1, 1, 1, 1, and so on. All the numbers are of this form. You can say that? Yes. So, uh, what is the divisibility rule for 3? Which is sum of the numbers equals to 3. So, uh, okay, we have n factorial numbers. Total we have n factorial number. So, 3 factorial, 2 factorial equals to 2, and 3 factorial equals to 6. Okay, then 4 factorial equals to 24, and so on. So you can see in 3 factorial there will be 6 digits. Okay, and 6 digit will be of type 6 digit will be look like this only. They are 6 ones. Yes, so this will look like this only. Okay, so if we sum all the numbers, we will take the d factor out and we will sum the remaining number. It will give us 6. So 6 into something, 6 into something is divisible by 3 always. Yes, you can say that. Yes. So after that, all are multiple of 6 only, or you can say 3 only. So all the numbers after n equals to 3 are divisible by 3. Understood? I think you understand that. And we just have to check for n equals to 2 and n equals to 1, which done I have done manually. And for the divisibility by 5, the last digit should be equal to 0 or 5. As all the digits are equal to d in this number, so last digit will also equal to d. So I am directly checking whether d is equal to 0 or 5 or not. I don't have to check for 0 because in constraint d is starting from 2. So I only have to check from 5, but I have also done for 0 also. Okay. Okay. First I will explain you 9, then we will jump to 7. The divisibility by 7. Okay. So for 9, what I am doing is same as 3. After 3 factorial, there will be 4 factorial, then 5 factorial, then 6 factorial. And 6 equals to 2 into 3. So we will get 2 factors of 3 in the 6 factorial number. Okay, and after that we will get the 2 factors of 3 in all the numbers. And divisibility rule by 9 is sum should be equals to 9. So 3 into 3 will come after 6 factorial. So after 6 factorial, all the numbers will be divisible by 9. So after n equals to 6, all the numbers are divisible by 9. And if it is less than 6, then I am directly checking it, taking the factorial, then multiplying d into the number. So I am making the original number and directly checking whether it is divisible by 9 or not. It will be a 10 to the power 5 size number, so it is easier to calculate. So I am directly calculating it. Okay. Now let's see for n equals to 4. divisibility by 7. Okay, so it is a little bit interesting. I hope I will be able to explain you this. Okay, so we can write these number as d 1, 1, 1, 1, 1, and so on. Okay, so okay, this 1, 1, 1, 1, 1, can I write it as 10 to the power something? You can say k minus 1 divided by 9. See if it makes sense. Yes, it makes sense. Anything, it will be like the number will be like this, and if we minus 1 in that, then it will look like this, and if we divide it by 9, then we will get 1, 1, 1, 1, 1, and so on. So yes, we can write this number as this, d into this. Okay, okay. For now, let's leave this d aside and focus on this only. So to make it divisible by 7, we have to make 10 to the power k uh, mod 7 equals to 1. Okay, so if we make uh, 10 to the power k mod 7 equals to 1, then it will be 1 minus 1 by 9, so it will be 0. So if there is a number 10 to the power k that gives mod 7 equals to 1, then we will get this number divisible by 7. Understood? Okay. So when it is possible uh, to get 10 power k mod 7 equal to 1, so there is a theorem. Uh, I am forgetting his name. I think it's Euclid's little Fermat's little theorem. So it says if it is something like a to the power phi of p, and it is modulo by uh, p, then it will give us 1 always. Okay, and p is a prime number, and phi of p is always p minus 1. So if it is like a to the power p minus 1 mod p, it will always give us 1. Okay, so uh, a to the power p minus 1, a is equal to 10, p minus 1 is k. Okay, p is 7, so p minus 1 equals to 6. So our k should be of form should be a multiple of 6. Understood? So what is our k here? K is the number of uh, ones here, which is equals to n factorial, because how many d's are there? N factorial d's are there. So k will be equal to n factorial. So our n factorial should be divisible by 6. Okay, so 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is, you can say, 4 into 6, and this goes on. So all the factorial above 3 factorial are divisible by 6. So k all the k uh, are so you can say all the factorial above 3 factorial are divisible by 6. Okay, so if all of them are divisible by 6, so for all n greater than 3 greater than equals to 3, it is divisible by 7. Understood? I think I am able to explain you that. So I did the same. I checked for all n greater than equal to 3. I am directly saying yes, it is divisible by 7. And other than that, I am just checking whether d is equals to 7 or not for n equals to 1 and 2. As all the numbers are of form d into 1 1 1 1 1. So the only number that is divisible by 7, which is n less than 2, l less than equals to 2, it is 77 and 7. So uh, whenever d is equals to 7, then only we will get 7 and 77. So I am directly saying if n is greater than equals to 3 and d is equals to 7 or d is equals to 7, then it is divisible by 7. So that's how we are doing this question. I hope you understand that. Okay. Then after that, we solve this question. This is also 800 rating question. It is also easy. Okay. I'll directly walk you through the solution. Okay. First, to understand the question. We have given an array of numbers, and uh, we have to create a permutation of these numbers in a way that okay, let me show you that a1 comma a2 comma a3 comma a4 and so on. ठीक है? So we have to arrange them in a way that a a2 mod a1. Oh, wait a minute. Yes, okay, I'm right. A2. Wait a minute. Wait a minute. Yes, yes, yes. A1 mod A2 is equals to A3, then A2 mod A3 equals to A4 and so on. So we have to arrange them in this way. If so, if we are able, wait a second, yes. So if we are able uh, to do this, then we have to just print the first A1 and A2. Understood? So let's see this array. We have 3, 8, 13, 5. So we can arrange this in a way like 13, 8, 5, 3. So 13 mod 8 equals to 5, 8 mod 5 equals to 3. So this array is a valid array. So we have to return 13 and 8. So we are returning 13 and 8. Similarly with this and all of this. So it is very simple question. What you can do is you can sort the array in decreasing order 13, 8, 5, 3 and just directly check whether this element is mod this, 13 mod 8 equals to this element or not, or 8 mod 5 is this element or not. You just directly have to check it. Why? Why this solution works? Okay. If you create any other permutation, so it will be like, uh, other than this, any other permutation will be of, will look like 13, 5, 8, 3. Now, uh, 13 mod 5 equals to 3. So here you can see that 8 cannot be the solution of this. मतलब 13 mod 5 cannot be 8 at all. Okay. So anything because A mod B will all or will always give us a C which is less than B. Do you understand that? I hope you understand that. So we can't create any other permutation other than a decreasing sequence because every number should be less than the number before it. Otherwise, it will not create a permutation at all. Okay. So we have to only check in the decreasing order whether all the elements are mod of the previous two elements, like 13 mod 8 equals to 5 or not, or 8 mod 5 equals to 3 or not. We have to check only like that. Okay, so that I have written the code also. I have sorted it in decreasing order. Then I have started a loop. I am just checking previous second last number mod last number is equals to cover current number or not. If yes, then continue. If no, at any point if it is breaks, then I am just terminating the loop and I have made a flag and making the flag as false, then just printing -1 if it is not possible, and if the loop continues till the end, then our flag will remain true. Then I'll print the first two elements of our array. So that's how the solution works. This is again a very easy question. So yes, I've been also trying a 1518 question. I was a little stuck in this, but I think I can do this if I give a little more time to it. So yes, that's how we have done a total of 5,000 some rating questions today. And with that, I'll do more questions tomorrow, and will live stream tomorrow most probably. So yes, that was for today. I'll see you in next video. Bye bye. And if you have any doubts in the explanation and all, so you can comment it down. Bye.